Hello and greetings to everyone. We will continue from where we ended last time with the correction of the following exercise for application. It says write down the factors of the following. Here we have 7. Number 7. We have to write down f of 7. F of 7 will simply be equal to plus or minus 1 plus or minus 7. This will simply be equal to negative 7, negative 1, 1, 7. We go now to B. For B, we have the number 10. We need to write down f of 10. F of 10 will simply be equal to plus or minus 1, plus or minus 2, plus or minus 5, and lastly plus or minus 10. This will simply be equal to negative 10, negative 5, negative 2, negative 1, 1, 2, 5, 10. We go now to C. For C, we have the number 25. We need to write down f of 25. It will simply be equal to plus or minus 1, plus or minus 5, and lastly plus or minus 25, which is simply equal to negative 25, negative 5, negative 1, 1, 5, and lastly 25. We go now to D. For D, we have the number 30. We have to write down f of 30. This will simply be equal to plus or minus 1, plus or minus 2, plus or minus 3, plus or minus 5, plus or minus 6, plus or minus 10, plus or minus 15, and lastly plus or minus 30. This will simply be equal to negative 30, negative 15, negative 10, negative 6, negative 5, negative 3, negative 2, negative 1, 1, 2, 3, 5, 6, 10, 15, and lastly 30. We go now to E, the number 50. We have to write down f of 50. F of 50 will simply be equal to plus or minus 1, plus or minus 2, we have plus or minus 5, plus or minus 10, plus or minus 25, and lastly plus or minus 50. This will simply be equal to negative 50, negative 25, negative 10, negative 5, negative 2, negative 1, 1, 2, 5, 10, 25, and lastly 50. We go now to the last question, which is question F. For question F, we have the number 125. We have to write down f of 125. This will simply be equal to, we have plus or minus 1 the first, plus or minus 5, plus or minus 25, and lastly plus or minus 125. This will simply be equal to negative 125, negative 25, negative 5, negative 1, 1, 5, 25, and lastly 125. Now we move to the next thing, which is prime numbers. That's 4 prime numbers. Most often we make use of the word prime. IV, write down the factors, of the following. Write down the factors of the following numbers. We have 2, 3, 5, 7, 11, 13, and 17. Let's write out f of 2. You know f of 2 will simply be -2, -1, 1, 2. Next, we have to write f of 3. f of 3 we have -3, -1, 1, 3. Next, we have to write f of 5. f of 5 will simply be -5, -1, 1, 5. Next, we have to write f of 7. f of 7 will simply be equal to -7, -1, 1, and lastly 7. Next, we have to write f of 11. f of 11 will simply be equal to -11, -1, 1, 11. Next, we go to f of 13. f of 13, we have -13, -1, 1, and lastly 13. Next, we go to f of 17. For f of 17, we have -17, -1, 1, and lastly 17. Looking at the factors of each of these numbers, you will discover that each of these numbers has two positive factors, being 1 and the number itself. You can see for 2, 1 and 2, these are the positive factors. 1 and 3, positive factors. 1 and 5, positive factors. 1 and 7, positive factors. 1 and 11, positive factors. 1 and 13, positive factors. And lastly, 1 and 17, positive factors. Now, what is a prime number? A prime number is a positive whole number, which has only two positive factors, being 1 and the number itself. I will underline this definition with a red pen. It is very, very important. Take note of this. Very important to know this definition of a prime number. Next, let's write this down. The numbers 2, 3, 5, 7, 11, 13, and 17 are all examples of prime numbers. Now let's take a hyphen by the margin. A number a number with more than two positive factors is called a composite number. It's called a composite number. Now let's note this down. It's very important. Note. If we write out the factors of the number 1, we have -1 and 1. In this case, you'll see that the number 1 has just one positive factor, which is 1, the number itself. Let's write this down. The number 1 is not a prime number. So you take note of this. 1 is not a prime number. It's not a prime number. Since 1 has only one positive factor, which is itself. Underline this. Number 1 is not a prime number. Most often you see people giving 1 as a prime number, which is not true. We take now a hyphen by the margin. The prime factors of a number n, n is a whole number, a positive whole number, denoted as, so this is how we denote the set of prime factors of a number. It is a set. Pn is the set, we take note, it is a set of factors, of the number n, the factors of the number n that are all prime numbers. For example, let's write down the prime factors of the number 6. Prime factors of the number 6, we have 2 and 3. Next, the prime factors of the number 30, we have 2, 3, and 5. We take now the next hyphen. Prime factorization, underline the word, underline prime factorization with a red pen. Prime factorization of a composite number is simply the expression of the composite number as a product of its prime factors. As a product of its prime factors. For example, if we take the number 10, we can write 10 as 2 times 5. 2 and 5, they are prime numbers. The number 15, we can express 15 as 3 times 5. 3 and 5, they are prime numbers. 3 times 5 is the prime factorization of the number 15. Next, if we take the number 20, we can write 20 as we divide 20 by 2, it gives us 10. 2 times 10. 10 is not a prime number. We can divide 10 by 2. If we divide 10 by 2, it gives us 5. Write this down as 2 times 2 times 5. This will simply be the same as if we apply index forms here. This will give us 2 raised to the power 2 times 5. This is a prime factorization of the number 20. Now if we take the number 30, we know 2 is a prime factor of 30. 2 times 15 gives us 30. This will simply be equal to 2 times, 15 as a product of its prime factors will give us 3 times 5. 2 times 3 times 5. 2 times 3 times 5 is the prime factorization of the number 30. To carry out prime factorization, of any composite number, we divide the number by prime numbers, starting from the smallest prime number. The smallest prime number is 2. Starting from the smallest prime number 2. Then from there now we can express the number as a product of its prime factors. If the number is not divisible by the smallest prime number 2, we try the next 3. If it is not divisible by 3, we try the next, which is 5, and so on. The next hyphen, when a number means a composite number is expressed as a product of its prime factors, in bracket, the number is prime factorized, as a product of its prime factors, number is prime factorized, it is very easy to get the prime factors. Very easy to get the prime factors of the number. If I write this down, n equal to s times t times u times v, s times t times u times v is the prime factorization, is the prime factorization. That means these numbers s, t, u, v, they are prime numbers. They are different prime numbers. Is the prime factorization of a number n. You can see this is n. Then p of n, the prime factors of the number n, will simply be equal to, we are simply going to write down the prime factors s, t, the prime numbers we see in this product, we are going to write it down s, t, u, and v. Underline this to the rep and you take note, it's very important. Let's take example, so you'll see how we can apply this. Find the prime factorization. Find the prime factorization of 40 and the prime factors of 40. We're going to take down solution. First, we are going to start by dividing the number 40 by the smallest prime number, which is 2. We are going to apply this. 40 divided by 2 gives us 20. That means we can express 40 as 2 times 20. Next, 20 is a composite number. If we divide 20 by 2, it gives us 10. This will give us 2 times 2 times 10, which will simply be equal to 2 times 2 times 10 divided by 2 gives us 5 times 2 times 5. So applying the rules of power, here we are going to obtain 2 raised to the power 1 to 3 times 5. This is the prime factorization of the number 40. Next thing we have to write the prime factors of 40. We said P40 will simply be equal to, we are simply going to copy all the prime numbers we see in the prime factorization as a product. You can see here we have 2 and 5. 2 and 5. Take note, 3 here is not to be copied. 3 is simply the power of a prime factor 2. It simply means in the prime factorization, the prime factor 2 is being multiplied by itself 3 times. The prime factors will simply be 2 and 5. Underline the result. Now let's take an exercise for application on this. Exercises for application. The first question goes, question 1 says write down the prime, write down the prime numbers between 1 and 50. Question 2 says find the following. Find the following. For A, we have to find P of 12. For B, we have to find P of 21. For C, we have to find P of 144. And lastly, for D, we have to find P of 255. We go now to question 3. It says find the prime factorization of the following numbers and hence write down the set of prime factors of each of the numbers. For A, we have the number 64. For B, we have the number 81. For C, we have the number 240. And for D, we have the number 369. We take down solution. The first one, question 1, it says we should write down the prime numbers between 1 and 50. First, we know that 1 is not part of this set. We know 2 is a prime number. 3, 4 is not a prime number. 5 is a prime number. 6 is not a prime number. 7 is a prime number. 8 is not. 9 is not. 10 is not. 11 is a prime number. 12 is not. 13 is a prime number. 14 is not. 15 is not. 16 is not. 17 is a prime number. 18 is not. 19 is a prime number. 20 is not. 21 is not. 22 is not. 23 is a prime number. 24 is not. 25 is not. 26 is not. 27 is not. 28 is not. 29 is a prime number. 30 is not. 31 is a prime number. 32 is not. 33 is not. 34 is not. 35 is not. 36 is not. 37 is a prime number. 38 is not. 39 is not. 40 is not. 41 is a prime number. 42 is not. 43 is a prime number. 44 is not. 45 is not. 46 is not. 47 is a prime number. 48 is not. 49 is not. And 50 is not. We are going to end here. So these are the prime numbers between 1 and 50. Go now to question 2. Question 2 says we should find the following. For A, we have P of the number 12. P of 12, prime factors of 12. The first one we have 2, the next we have 3. 2 and 3 are the prime factors of 12. For B, we have P of 21. P of 21 is simply equal to prime factors of 21. We have 3 and 7. We go now to C. We have P of 144. P of 144 is simply equal to, 144 is the same as 12 times 12. So the prime factors of 144 will simply be the prime factors of 12, 2 and 3. Go now to D. For D, we have P of the number 255. This will simply give us P of 255 to be equal to, we know if you take 255, we divide by 5, it gives us 51. And 51 is a prime number. So the prime factors of 255 will simply be 5 and 51. We are done with question 2. We go now to question 3. Question 3 says, find the prime factorization of the following numbers and hence write down the set of prime factors of each of the numbers. For A, we have the number 64. We know 64, if we divide 64 by 2, it gives us 32. It simply means 2 times 32 will give us 64. This will simply be equal to 2 times, 32 divided by 2 gives us 16. 2 times 2 times 16. This will simply be equal to 2 times 2 times 16 divided by 2 gives us 8. This will be equal to 2 times 2 times 2 times 2. 8 divided by 2 gives us 4. This will simply be equal to 2 times 2 times 2 times 2. 4 divided by 2 gives us 2. So this will simply be equal to 2 raised to the power 1, 2, 3, 4, 5, 6. Since we are multiplying the number 2 by itself 6 times. This is the prime factorization of 64. Next thing now, we need to write down the prime factors of 64. For us to get the prime factors of 64, we are simply going to copy the prime factors we see in the prime factorization of 64. In the prime factorization of 64, the only prime number we see is 2. So the prime factors of 64, we have just 2. And we are done with this. We go now to question B. B, we have the number 81. 81. If we divide 81 by 2, there's a remainder. Now we need to divide 81 by the next prime number, which is 3. 81 divided by 3 gives us 27. This will give us 3 times 27. 27 divided by 2, there will be a remainder. If you divide 27 by 3, it gives us 9. This will give us 3 times 9. If we divide 9 by 3, it gives us 3. This will give 3 times 3 times 3 times 3. Which will simply be equal to 3 raised to the power 1, 2, 3, 4. So this is the prime factorization of the number 81. Next thing, now we need to write the prime factors of 81. The prime factors of 81, we are simply going to copy all the prime factors we see in the prime factorization of 81. So the prime number we see is 3. 3 is the only prime factor of 81. Next, now we go to question C. For C, we have the number 240. If we divide 240 by 2, it gives us 120. So 240 is simply equal to 2 times 120. This will simply be equal to 2 times 120 divided by 2 gives us 60 times 2 times 60. This will be equal to 2 times 2 times 60 divided by 2 gives us 30 times 30. This will be equal to 2 times 2 times 2 times 30 divided by 2 gives us 15 times 2 times 15. This will give us 2 times 2 times 2 times 2 times, we know the prime factorization of 15 is simply 3 times 5. So this will give us 2 raised to the power 1, 2, 3, 4 times 3 times 5. So this is the prime factorization of the number 240. The next thing that we need to write down the prime factors of 240. The prime factors of 240 will simply be 2, 3, and 5. We go now to the last question, which is question D. For D, we have the number 369. 369, if we divide 369 by 2, it leaves a remainder. If we divide 369 by 3, it gives us 123. 369 is equal to 3 times 123. The next, if we divide 123 by 3, it gives us 41. This will be equal to 3 times 3 times 41. We know 41 is a prime number, so this will simply be equal to 3 raised to the power 2 times 41. So this is the prime factorization of the number 369. Now we are to write down the prime factors of the number 369. The prime factors will simply be 3 and 41. We are done with the correction of the exercise for application. If in case you have any worries, make sure you ask your question at the comment section. Like the video, share, and please do not forget to subscribe to this YouTube channel. Thank you very much for watching.